Hello students, welcome to the second lecture of the organic series, that's reaction mechanism, types of catalyst and their uses. So let's begin with our very second lecture today. So before beginning, do you know what is a reaction? Let's see. The breaking of old bonds of the reactants and the formation of the new bonds in the product inside a single process is known as a reaction. Means when the bonds of the reactant, suppose we have a bond of chlorine and chlorine, this is the old bond, and now we have to make hydrochloric acid from it. So we react it with H2. So the chlorine chlorine bond breaks up, hydrogen hydrogen bond breaks up, and the new bond this happens in the reactant, and the new bond of hydrogen and chlorine forms in the product. So breaking of old bonds in the reactant and formation of new bonds in the product in a single process, because the reaction is a single process. You have one atom of chlorine, you have one atom of hydrogen, and you get two atoms of hydrochloric acid. So this is a single process. So this is a reaction. Now we have to study 8 key features of a reaction. First is the reactant, second is the reagent, third catalyst, fourth reaction conditions in which mainly we study about temperature and pressure, fifth is activation energy, sixth is transition state, seventh is intermediate, and eighth is product. Each reaction has its own energy profile diagram. What is the energy profile diagram? Energy profile diagram means a diagram which represents the different energy levels and energy changes that occur in a given chemical reaction in a single graphical representation. So, if you want to learn and how to make an energy profile diagram and what is it and how to represent it on paper, so email me #profile, and after 100 emails I would be arranging a live Google Meet session with you on this topic. Next, we would have to study some basics of a chemical reaction. These basics are related to how we can write a chemical reaction. Acha, before going to these basics, do you know why are we studying this chapter? We are studying this chapter as your 12th is based completely on organic reactions. This chapter gives you a basic idea of the organic reactions and the functioning of catalysts and reagents so that you would be able to bifurcate which catalyst works where, how, and when, as direct questions are asked on these chapters of 12th. So let's begin with the basics. First is the reaction, the reactants. My bad, sorry. The reactants are always written on left side. Second, products are always written on right side. Third, reagent and products are separated by an arrow, tail towards reactants and head towards products. Fourth, reagent can be written along with the reactants on the arrow as well. Fifth, catalysts are always mentioned on the arrow. Sixth, reaction conditions are always mentioned on arrow. Do you know that reagents can also be written with the along with the products, or they can be written on the arrow also? Now let's study one by one all the components in depth. First, the reactants. The species that is consumed in a reaction is known as a reactant. Means, as we studied in the earlier example, that chlorine and hydrogen. So both the reactants were consumed. Hydrogen gas was consumed and chlorine gas was consumed to form hydrochloric acid. Second, the reagent. It reacts with the reactant to produce the products. In our example, chlorine was our reactant and H2, though it was a reactant, though it was in the reactants, but it acted as a reagent to form hydrochloric acid. Means the reaction was of hydrogenation of chlorine. Third, catalyst. It helps the reactant to reach the threshold energy level. It does not participate in the reaction, it alters the activation energy levels. When we will study the energy profile diagrams, you would get to know deeper about activation energy, but now take a basic idea that it is the energy which is to be achieved by the reactants to get transformed into products. So the catalyst just alters the energy level and helps the reactant to reach that energy level. It does not participate in the reaction, it remains the same throughout the reaction. Means if we use AlCl3 as a catalyst, AlCl3 will remain as AlCl3 only in the entire reaction. Fourth, the reaction conditions. The conditions of pressure and temperature under which a reaction takes place are known as reaction conditions. These are always written on the arrow separating the reactant and products. These can never be written alongside with the reactants or the products. You have to write it on the arrow only. It's the correct way of representation. Next is the activation energy. The threshold energy or minimum energy level required to be achieved by the reactant to get converted into product is called activation energy. So the activation energy is the energy level which that I also said earlier. That is the energy level that is required to be achieved by the reactants to get transformed into products. Fourth comes the transition state. You would get to know deeper about transition state also in the energy profile diagram only, but take a basic idea that the high energy state in which bonds of the reactant just start to break or the bonds of the product just start to form is called transition state. See, whenever, let's take a life example. Whenever we do something, a new work we do, and we have to close the old work and then start the new work. You agree? So, let's suppose you have some money in the stock market and you want to get it into your hand and invest the money in the property. Okay, basic thing. So first, your old bond is the stock market. It's a big process of breaking the bond with the stock market and taking your money back from there. So that period from from withdrawing your money and getting into your bank account, the middle stage is called the transition state, or the stage at which the invested amount is to be and the buying of your plot that you received the amount. After that, you have bought the plot. The between process is also transition state. It is the transition state inside the product, and that the previous one was that inside the reactant. Now let's see next. Intermediate. The moderate energy state in which reactant gets transformed into an unstable state in which, depending on the reaction conditions that we will provide, can get transformed into either back to reactant or to the product is called intermediate. Means intermediate is a highly unstable energy state. Its energy is very high, and you can expect that if the reactant, it depends that what reaction conditions we give to it. The intermediate, if we give it some reaction condition that is in the favor of the product, it would get transformed into the product. And if we give the conditions that are in the favor of the reactant, it will get transformed into the reactant. Means, this is a stage like you are in 10th and you are set to select that engineering or pharmacy, engineering or medical. So you can understand the stage very well. It's a very unstable state that you are unable to decide where to go. It depends on the conditions that you get from your surrounding, your colleagues, your peers, your family, and you decide and you take your decision. And the last thing is the product. This is the final ultimate goal of a reaction that we require. That's the basic thing, This is the example of a reaction. This is how a reaction is written. Reactant, reagent, catalyst, temperature conditions, pressure conditions, product. Now, the second part. Now let's move to the second part of the chapter. That is types of catalysts and their uses. So we have to study only two types of catalysts. First is the neutral catalyst. It does not alter the activation energy level or threshold energy level. Neutral catalyst does a basic thing that it takes the reactant and drops it to the energy level, the activation energy level, and releases it. But what does a positive catalyst do? It reduces the transition energy level. The activation energy level, it reduces it. See, the first previous energy level of the reaction is showed by the orange color. But after adding the catalyst, the energy level dropped down to the brown color. See, the catalyst has now reduced the energy level of the reaction. So the reactant can now move more faster and reach the activate energy more quicker and earlier and get transformed into product more quickly and more faster. Thank you. And I leave you with a question that if a positive catalyst reduces the threshold energy level, then what would a negative catalyst do? Do mail me this answer and I would be waiting for your response. The PDF of the notes will be provided in the description box. Please do check it and get it for your future reference. The next chapter that we would be studying will, will be GOC Part 1 and Part 2. It would be released on 21st of July. Actually, it's written 17th of July, but due to some issues and due to some things, we would be releasing it on 21st of July at 5 p.m. So stay tuned till then. Thank you.